API versioning is a bit like a game update, but without forcing everyone to jump to the new version immediately. There are several ways to handle it, and each has its flair and implications. In this video, I will dive into real-world examples from big names in the tech world to show the practical applications of different API versioning methods. Remember, strategic considerations drive your choice of versioning. URI versioning. In URI versioning, the version number gets its spotlight right in the API endpoint URL. For example, https api.example.com/v1/users clearly shows its version 1. This method is widely adopted. It's a hit among large companies and shines in public APIs where simplicity is prioritized. Major platforms like X or Twitter include the version in the URI. For instance, to fetch a single tweet, you would hit up https api.twitter.com/2/tweets/id. Azure API Management also supports this style. It offers a crystal clear path to different API versions. It makes it easy to distinguish between different versions of the same API. For instance, if you have a products API with two versions, v1 and v2, the URLs for accessing these versions would look like this. For version 1, /products/v1, for version 2, /products/v2. The general format for an API request URL when using path-based versioning is https:/your domain/API name/version identifier/operation ID. This approach has the following advantages. Visibility. The version is clearly visible in the URL, making it straightforward for developers to understand which version they are using. Simplicity. It's easy to implement and route different versions to the appropriate logic. The disadvantages or cons: clutter. Over time, the API path can become cluttered as versions increase. Rigidity. It's hard to deprecate gracefully because old URLs need to be maintained for compatibility. Parameter versioning. The second approach is parameter versioning, or version as a sidekick. With this approach, the version travels as a query parameter in the API call, such as api.example.com/users?version =2. It's great for developers looking to toggle between versions on the fly because it offers flexible testing. AWS services or Amazon Web Services use parameter versioning to keep track of API compatibility. You need to include the API version as a parameter identified by year minus month minus day formatted date string, like 2010 -03 -31. For instance, initializing a DynamoDB service might look like this: var DynamoDB equal new aws.dynamodb, and then you can mention your API version as a JSON config or JSON object, then API version 2011 -12 -05. You can also specify the API versions for the AWS services you want to use as follows: aws.config.api versions equal, then as a JSON object, DynamoDB, then the version for the DynamoDB service, EC2, then the version of the EC2 service you want to use, then Redshift, and the version for the Redshift service. As you can see here, you can mention just latest to use the latest version. As advantages, this approach offers flexibility. It's easy to mix versions within a single API call if parts of your API mature at different rates. Clean URL paths. It keeps the base URL clean and unversioned. The disadvantages or cons: less visibility. It's a bit of a hide and seek for the version info. You need to look at the full URL to find the used version. Complexity. Caching gets trickier because URLs that differ only by parameters are often cached separately. The third approach is header versioning. You can consider it also as stealth mode. Here, the version info hides in the HTTP request headers rather than in the URL. For example, API version, then 3. This practice is often used in corporate enterprise environments where the separation of concerns and long-term API management is crucial. For example, to tap into a specific GitHub API version, you include the x-github-api-version header with the desired version date. To use the version released on November 28, 2022, you would send a request like this: curl --header x-github-api-version :2022 -11 -28, then https:/api.github.com/z. If a request does not include the x-github-api-version header, it defaults to using the latest version available at the time of the request. However, specifying a version that is no longer supported will result in a 400 error. As advantages, this approach offers clean URLs. It keeps URLs neat and transitions between versions smoother. Decoupling. It separates versioning from the business logic URLs, which offers more flexibility in API infrastructure. Cons. As disadvantages, we have hidden versioning. Since the version is in the header, it's less visible and can be overlooked by developers. Implementation overhead. It requires additional setup in HTTP headers, which can be overlooked or mishandled more easily than URL changes. API versioning best practices. Effective API versioning is crucial for smooth operations and happy users. Here is how to ace it. Plan ahead, anticipate changes, and design your API with future versions in mind. This helps you to make informed decisions about the API's evolution and minimizes the need for significant changes later on. Keep it simple. Start with a simple versioning strategy that meets your current needs. Add complexity only when necessary. Simplicity in versioning makes it easier for both developers and users to understand and adopt the API. Document like a pro. Every versioning change should be well documented to clear up any confusion. This helps users understand what features and changes are available in each version and how to use them. Deprecate gracefully. Give plenty of notice before deprecating an older version and support users in migrating to newer versions. Semantic versioning. Use semantic versioning with the syntax major.minor.patch to clarify the nature of changes in each release. This standardized approach helps in understanding the impact of changes and planning for upgrades. Test across versions. Ensure new versions play nicely with old setups to avoid breakage. This helps in identifying and fixing issues early. Communicate clearly. Keep users in the loop about new versions and what they mean for them. Effective communication builds trust and ensures that users are prepared for changes. Enable backward compatibility. Keep versions compatible as much as possible to ease your users' pain. Techniques for achieving backward compatibility include adding new resources without removing or renaming existing ones, providing default values for new features, and using aliases for renamed or deprecated resources. Keep API docu fresh. Update API documentation regularly to reflect the latest and greatest. This ensures that users have access to the most current information. With the right strategy and commitment to best practices, API versioning can create a robust, flexible environment that fosters trust and reliability. Choose wisely and keep your developers and users in the loop. This way, both your API developers and users can have seamless experience. Excited about diving deeper into the world of software architecture? This video is just the beginning. Check out my Udemy video course on software architecture, where I explore these concepts further and dive into real-world challenges. The link to the course is in the video description below. And here is a bonus. Subscribe to my newsletter and you will get free access to all my courses. If you found this video helpful, don't forget to hit the like button and subscribe to the channel for more updates and tech insights. See you next time.